Electrolysis of molten electrolyte, or you can say ionic compounds. Electrolyte is anything which can conduct electricity because of the free ions. So molten electrolyte will be any molten ionic compound like NaCl. Okay, we can take here NaCl, sodium chloride. It's in the molten form. Okay, so now we have electrolytic tank over here. Okay, in which the electrolysis takes place, and it contains the molten electrolyte, that is a sodium chloride. Okay, this is in the liquid form. It's normally at room temperature it is in the solid form, but when it is heated up to 801 centigrade, then it becomes liquid, so molten NaCl. Okay, and then it contains electrodes which are dipped into it. You can also say submerged into it, and then they are connected to high voltage battery. This is the positive terminal, this is negative terminal. The electrode which is connected to the negative terminal is called cathode. It has negative charge, and the electrode which is connected to the positive terminal is called anode. Okay, it has plus charge, and this is a high voltage battery. Okay, here the electrons are pumped, okay, like this, and the here electrons are given back to the battery and are collected, okay, and received, you can say simply. So what we are going to study, actually it has the 4 steps which we need to know. First is the identification of ions. So we know that when NaCl is heated, so it converts into its moving ions, which are called cations and anions, and it has Na plus and Cl minus. These are cations of sodium and anions of chlorine. Okay, so when it is connected to the battery, what happens? Cathode is an electrode which has a negative charge, and on this reduction takes place. Okay, and as I have told you in the previous lecture, that cathode is electrode towards which cations move. Cations move towards the cathode. Cations have plus charge, cathode has negative charge, so opposite charges attract each other. Okay, reduction takes place. What is the reduction? Reduction is the rig. Simply, reduction is gain of electrons. Rig is the mnemonics to understand. Reduction is a gain of electrons. Okay, so you can see what will happen over here. Cations, there is only one type of cation, that's sodium. Okay, Na plus, it will move and it will gain electrons which are being released from cathode. So Na will gain electron and it will become Na solid. Okay, here it was the Na gaseous aqueous. Okay, because it was in the water and dissolved and dissolution form. Now sodium will be deposited on this. Okay, a layer of the sodium will be found over here. Okay, being the solid. On the anode, you know that anode has a positive charge, so anions will move towards the anode. Okay, anions have negative charge, so in this way there will be a force of attraction between the opposite charges. So on the anode, we know what happens. Oxidation takes place. And oxidation is oil. Oil means oxidation is a gain of is loss. Oxidation is a loss, okay, of electrons. I'm just adding to explain it a bit more. Okay, so the anions over here are the chlorine. Okay, chlorine will move. Why I'm writing two? Let me write just one. Oh, okay, wait, yes, and it will lose electron. Okay, and then chlorine gas will be released. So you know that to make the chlorine two atoms, we will have to take here two chloride ions, so each will lose one electron, so two electrons will be lost, will be given back to this. Okay, it will gain the electrons which the chloride ions have released. So it was in the aqueous form because it was dissolved. Now it has become gas. You know that chlorine is in the gaseous form, so its bubbles will be formed. So in this way, the electrolysis of any molten electrolyte will take place. Okay, we can take, instead of sodium chloride, we can take KCl, we can take MgCl. Okay, 2. So we can convert into the cations and anions by heating them. Okay, and they will become liquid and their ions will be mobile, their ions will be moving freely. So cations will be attracted towards the cathode and ions will be attracted towards the anode, and cations will be reduced. Okay, and anions will be oxidized on the anode. So this is a simple for the molten electrolytes. Okay, now we are moving towards the electrolysis of aqueous solutions of compounds. Electrolysis of aqueous solutions of electrolyte. We have electrolytes, okay, but they are not in the molten form. They have been dissolved in the, you know that electrolytes are mostly ionic, okay, or simply you can say simple covalent compounds, okay, polar covalent compounds, but all those are polar and they will dissolve in the water, dissolve in water. Okay, so when you have any ionic compound dissolved in the water, then we call it the aqueous solution. For example, I write here NaCl plus water. Okay, so it will become NaCl aqueous, means aqueous solution of water. Anything we have KCl plus water, it is dissolved in the water, so it will make the KCl aqueous. So look on the aqueous solution of the electrolytes. Okay, so suppose I'm writing here NaCl. Okay, I'm going to take it into consideration. NaCl aqueous, it has cation, as we know that Na plus and Cl minus, but the water which dissolves this NaCl, it is also a weak electrolyte, and it is also converted into the cations and anions. Okay, water is converted into the H plus and OH minus. So when we were studying the molten solutions of electrolytes, so we were not facing H plus and OH minus. We had no issues. Okay, simply cations were being attracted towards the cathode. Same will happen and this time as well. Okay, the same process will happen for the anions, but now one of them will be selected. They will be preferentially. You will be saying that you can say there will be selective selection. Okay, and one of them will be discharged, one of them from the anions will be discharged. Okay, so we need to know that how their discharging takes place and which one will be discharged. Okay, so now it has become a bit complex. Okay, so one of them will be discharged, we can say selective discharging. Okay, one of them will be selected for discharging. Okay, what is selective discharging? When we have more than one ions, cations or anions, so one of them will be preferred to be discharged. So it is called selective discharging, whether it is cation or it is anion. Okay, so we need to know some factors that how these will be discharged. Okay, just let me tell you that selective discharging of ions, selective discharging, discharge of ions. Okay, so there are three factors. First is selective discharge of cation. Second is selective discharge of anions. Okay, and one more thing is there, effect of concentration on the selective discharge of anions. Okay, effect of concentration on the selective discharge of anions. Okay, now we will study selective discharge of cations first. I'm going to write here the reactivity series. You understand what is the reactivity series? Okay, reactivity series. Okay, the ions which are ionized and which are more reactive are written first. Please send camels, monkeys, okay, zebras in large or heavy crates soon. Please send camels plus 2, monkeys magnesium plus 2, zinc plus 2, Fe also plus 2. Okay, in large heavy plus copper it is a plus 2, and silver soon it is plus. So let me tell you what we are going to study over here. This is a reactivity series. Okay, means it is the most reactive, it will be ionized very quickly. Okay, so that's why it is on the top of the reactivity series. Then even then sodium, it releases its electrons after potassium, so it is on the second number. Okay, so you can say the reactivity decreases from top to bottom. Okay, reactivity series means the a series which arrange the metals from the most reactive to the least reactive. You can say arrangement of metals from most to least reactive. Okay, so you can see the ease of discharging increases. Ease of discharging increases from top to bottom. Ease of discharging increases means lower one will be discharged preferentially than the upper one. Okay, will be discharged first than the upper ones. Okay, so ease of discharging increases. You can say that as the silver it will be discharged first even before the copper, and when the copper and the hydrogen are present, the copper will be discharged first. When the hydrogen is present, and so it will be discharged first then the above ones. Okay, so you can say that in this way, ease of when it's easy for cathode to discharge silver as compared to copper, and copper as compared to hydrogen, and hydrogen as compared to lead as compared to the iron. So in this way, simply I can say that the lower ones are discharged first and they are preferred to be discharged by the cathodes. Means you can say simply that the reactivity series here we have, okay, the ones which are ionized hardly, which are the least reactive, but those are discharged first. Okay, the least reactive ones are discharged preferentially. So here I'm just going to tell you that the sodium and potassium do not get discharged. Okay, when they are in the aqueous solution. Okay, and when they are in the aqueous solution, when they are in aqueous solution, not at all, they won't be discharged in the aqueous solution. Okay, so we have these ones. Hydrogen, if we have aqueous solution, Okay, so if we have calcium and then we have hydrogen, when we have the aqueous solution, then it means there will be hydrogen. Okay, we so hydrogen will be discharged, okay, in preference to the ions metals which are above in the reactivity series. Okay, H plus will be discharged, okay, preferentially, or you can say in preference to the ions above it. You can simply see over here that the ions which are above it, it's hard for them to be discharged, so that's why we can say hydrogen will be discharged. It's easy for hydrogen to be discharged, so that's why when we have the aqueous solution, so hydrogen will be discharged, okay, as compared to the calcium, magnesium, zinc, lead, and you can say iron and lead. Okay, so hydrogen will be discharged first, and when we have the copper and silver, so they are even lower than the hydrogen, and we have the aqueous solution of copper and the silver, then instead of hydrogen, copper will be preferred, because the silver will be preferred because they are lower. In they are, you can say, it's easy for the copper and the silver to be discharged as compared to the hydrogen. Okay, so ions of the metals below hydrogen will be discharged. Ions of metals below hydrogen will be discharged. Okay, I'm writing here shortly. You have to identify. We have magnesium and then hydrogen. Okay, we have zinc, then we have hydrogen. We have copper, then we have hydrogen. We have simply calcium, and the second is you can say that you have hydrogen. So which one of them will be selected? When magnesium is above in the series, so hydrogen will be preferred to be discharged, okay, by the cathode. So zinc is above in the reactivity series than the hydrogen, so hydrogen will be preferred because it's easy for cathode to discharge the hydrogen. Copper and the hydrogen, so here what will be selected? Copper and hydrogen. Copper, definitely, because copper is lower than the hydrogen. Okay, so copper will be selected for discharging, and hydrogen will remain in the solution. Okay, and here calcium and hydrogen, so hydrogen will be preferred to be discharged as compared to the calcium. Okay, so calcium will remain in the solution, here the hydrogen will remain in the solution, zinc will remain in the solution, and magnesium will remain in the solution. Okay, and the others which I have circled, okay, they will be discharged because it's easy for them to be discharged. Okay, this is all about the reactivity series or selective discharging of the cations. Okay, now we are moving towards the selective discharging of anions. I'm writing here some of the anions which are famous on sulfate SO4 minus 2, nitrate NO3 minus, then what we have, chloride, bromides, okay, iodides, and hydroxide. Same happens over here, that ease of discharging increases, means lower will be discharged first as compared to upper ones. So definitely when we have the aqueous solution, so hydroxide will be preferred. Okay, in case of aqueous solution there will be hydroxide, so it will be preferred. Okay, so you can say hydroxide releases electrons in preference to above anions. And there is one famous equation for the hydroxide which you have to understand: 4OH minus, 4 hydroxide will release the 4 electrons, so I'm writing here 4 electrons. Okay, so we have 4 hydrogen and 4 oxygen, so 4 hydrogen and 2 oxygen I have used over here, it will be in the liquid form, so 2 hydrogens are remaining, so sorry, 2 oxygen, so it will be released in the form of the gas. Okay, So this equation you have to understand. These hydroxide are in the aqueous form. But this is the selective discharging of anions. Okay. So, but one more thing which affects the third factor, which is the effect of concentration. Effect of these both will not be discharged. Not at all. Okay. They prefer to remain in the solution. Okay. Effect of concentration on the discharging of anions. This is the third factor which you have to understand. This was the second. Okay. So effect of concentration. When we have concentrated solution, okay, then selective discharge of anions, the process, or you can see the procedure, or you can see the simply the trend of discharging of anions will be reversed. Okay, in case of the concentration of solution, so discharging will be preferred in reverse trend. Okay, for anions. Mainly you have to understand. Okay, I'm writing here, suppose you have dilute solutions. Okay, when you are given solutions, it's not mentioned that those are concentrated. Okay, then you can take the dilute. For example, you have sulfate SO4 minus 2, and then you have hydroxide. You have chloride, and then you have hydroxide. Definitely when we take the aqueous solution, so it contains the hydroxide ions as well. When we have iodides, so that there will be hydroxide. Okay, so we have iodide, and then there is hydroxide as well. Here I'm writing concentrated. When we have chlorides and hydroxide, then here is the concentrated. Based on the second factor, these are all dilute. When it is mentioned dilute, so it is still dilute, and when even if it is not mentioned, then you can take it the dilute. But when those are concentrated, then definitely they have to mention. Okay, otherwise you have to take it dilute. So in case of dilute, so hydroxide will be preferred, it will not discharge. In case of dilute, if it is not written, then we take it we consider it dilute. Okay, so hydroxide will be preferred, so we use the above equation. Okay, hydroxide will be preferred. But when we use the concentrated solution, so hydroxide will not be preferred. Okay, the above the trend will be reversed. Okay, so above anions will be preferred, means iodide will be, you can say, discharged, chloride will be discharged, and the hydroxide will remain in the solution. Okay, so here the third factors, the effect of concentration on the discharging of anions. It only affects anions, not the cations. Keep it in your mind. Okay, so now we are going to practice the electrolysis of the dilute sodium chloride. Electrolysis of dilute sodium chloride. Actually, you have to understand 4 steps. First step is select, or you can say identify the ions. Okay, whether those are cations or anions. Cations are anions. You have to identify them. For example, in case of dilute NaCl, you have to identify NaCl aqueous. It is okay, it is dilute, so you know that it has Na plus and Cl minus. Okay, and H plus because it is the aqueous, and OH minus. Is it clear? So you have identified. This is the first step you always have to do. Okay, and I have given you an example. Okay, a second, you have to determine the anion which has to be discharged. Okay, secondly, you have to identify or determine, or you can say you have to select anion being discharged. Okay, what we have, suppose we have anion chlorine, chloride, anion, and hydroxide. So in case of dilute, when it is mentioned that it is the dilute, okay, so what will happen? So you will definitely prefer hydroxide, it will be discharged, okay. But if you are told that you have concentrated chlorides and hydroxide, okay, so concentration only affects the discharging of the anions, then you have to prefer chloride, although it is above in that series, okay. It's hard for chloride to be discharged, but in case of concentration it will be preferred and it will be discharged as compared to the lower one, hydroxide, okay. And one more thing that you have to know, that sulfate and nitrate, NO3, even if we take the concentrated form, they will not be discharged, they will not be discharged, okay, discharged, they won't be discharged. These three things, they won't be discharged. Even if we take the concentrated solution, they won't be discharged, they will remain in the solution. But if we take the concentrated solution of chloride, okay, then chloride or iodide, bromide, they will be discharged definitely. But if we take the dilute, then hydroxide that comes in the lower, okay, and it will be easy for hydroxide to be discharged. Third thing is select cations being discharged. So you know that in case of, here we have sodium chloride dilute, okay, so H plus we have, and Na plus. So you know that hydroxide hydrogen, okay, it will be preferred, it will be discharged. Even if we take the concentrated, but concentration does not affect the cations, okay. But you must know that sodium and potassium, okay, they will not be discharged in aqueous solution, in aqueous solution, okay. But you must know that the ions lower than the hydrogen, means the copper plus 2, okay, when it is compared with the hydrogen, okay, and Ag plus then hydrogen. So those easy for them to be discharged is for the copper and for the silver, okay, as compared to hydrogen. Then this will be selected. And the fourth factor is identify the cations and anions which remain in the solution. Cations and anions which remain in the solution. Which remain in the solution, okay, remain in the solution. Now let's move towards the practice, okay, we need to practice it. Dilute NaCl aqueous, okay. So first step is identify cations and anions, okay. I'm writing here, trying to draw the electrolytic cell, and here are the electrodes. One is called cathode and one is called anode, okay. Plus charge, so this is the anode and this is cathode. Minus charge, it has plus charge, and here is what is dilute NaCl, okay. Dilute NaCl means you can say simply, okay. So here we have battery. So let's do the procedure. Select the ions, cations, anions. So cations are Na plus and H plus because of the aqueous solution. chlorides, anion, and then hydroxide because of the aqueous solution. What will happen on the cathode? You know that what happens over here? Reduction. Reduction is the rig, is the gain of electron. So both of them will be attracted. Na plus will also be attracted and H plus will also be attracted, but one of them will be discharged. Don't say that one of them will be attracted. Both of them will be attracted because both of them have the positive charges, okay? But one will be preferred. Which one? Hydrogen. You understand, because it comes below the reactivity series, uh, than the than the sodium, and it's easy for hydrogen to be discharged, okay? So 2H plus each will gain because it releases electrons, okay? In this way electrons are released from the cathodes. Electrons are released, okay? So 2 electrons will be given to two of the these cations, so H2 gas will be formed, okay? But on the anode, what happens? On the anode, one of them will be selected. This is dilute, okay? This is in case of dilute. So on the anode, what happens? Oxidation takes place. Oxidation, okay? Oxidation, you know, oil is the loss of electron, okay? Okay, is the, and then what will happen over here? Let me make it clear that we have two anions. Those will be attracted towards the anode, okay? Cl minus and OH minus. So in case of dilute, we know that hydroxide will be preferred, so it will be discharged. So 4OH minus will form 2H2O. You have to keep it in your mind. O2 gas, okay, and plus 4 electrons. So 4 electrons will be given to it, okay, and those are given back to the battery, will be found back to the battery, okay? And oxygen being the gas will be released from here, okay? And 2H2, that is the liquid, it will be okay, it will remain in the solution, okay? And hydrogen in the form of the bubbles, oxygen in the form of the bubbles will be released. What's the remaining? You identify the fourth step. Is this is the third step, okay? First step, what happens on the cathode, or you can take the anode first, okay? This is the third step. What happens? Summary, what is the remaining, okay? So we have to identify what is, sodium is remaining and the chlorine is remaining, okay? Na plus plus Cl minus, okay? So NaCl. But here H and here from here OH are released, so it means we can say that the solution of sodium chloride, that is the aqueous solution, will become concentrated, will gradually become concentrated. Okay, now we take the you can have a look on this, okay? I'm just going to make it a bit clear to you, okay? You have to understand the procedure. Identify the cations and anions. What happens on the cathode? One of them will be selected, hydrogen, okay? And on the what happens on the anode, this third step, one of them will be selected, preferred for the discharging, okay? One of them will be discharged. The remaining which have not been discharged will be written in this step, okay? And we can write here that we have NaCl aqueous. Here I'm taking the concentrated sodium chloride solution, okay? This is of course aqueous solution but concentrated. So I'm writing here first step after drawing the diagram of the electrolytic tank, minus plus, it will be cathode, minus charge, okay? Cations will be attracted towards the cathode, okay? Anode, plus charge, anions will be attracted towards anode, okay? This is the battery. First step, what is the first step? Selection of ions. So Na plus, Cl minus, H plus, OH minus. Here is concentrated. What happens on the cathode? One of them will be selected, okay? On the cathode, what happens? Reduction happens. Reduction takes place. Reduction is the gain of electron. Okay, so we have two, both of them will be attracted towards the cathode. One of them will be preferred, that is the H, because it is easy for the cathode to discharge the H plus. Okay, so 2H plus, each will gain one electron, so this will happen. Okay, so gain of electron, reg is the gain, reduction is the gain, so it's the gain of electron. You can say simply, see simply over here. Okay, and what is anode? Anode is the oxidation. Okay, and what is oxidation? Oxidation is oil, is the loss of electron. Okay, so you can see over here anode, we will have two anions, chloride and hydroxide. Okay, one of them will be preferred. Here chloride will be preferred because it is concentrated. Otherwise, if it is not concentrated, then we take the hydroxide. So what will happen to chlorine? Each will release electron. Oil is oxidation is the oil, means the loss of electron. So chloride ions will lose electrons, so two will lose, two chloride anions will lose two electrons, so we will get the chlorine gas. Okay, over here. So fourth step is the remaining. This was the first step, this was the second step, this is the third step, and this is the fourth. Okay, so fourth one we have Na plus, this is the remaining from here, and hydroxide from here. So what will be formed? NaOH will be left over here. Okay, and so this will be aqueous. One more thing which we need to study, we had to study it before, but now I'm going to tell you over here right now that there are two types of electrodes. Okay, which types of electrodes will be used over here? Here the chlorine is being released, it is the gas, and it will be released over here. Okay, so if we take here any reactive, okay, so it will react with that. So what we take here, we take the inert electrodes which will not react the chlorine, because chlorine is very reactive. Okay, so in case of concentrated sodium chloride, we take here the, both of them are the anodes, electrodes are of two types. I'm writing here downward. Electrodes are of two types: reactive electrodes, and the second is inert electrodes. Okay, reactives which react with the products, with the substances or the products, okay, formed. The newly formed products react with those, so that's why those are avoided and those are prevented. And inert are those which do not react with products, okay, formed. So mostly we use the copper, we use platinum. Okay, it's inert. And second is the carbon in the form of graphite. Okay, it can conduct electricity because of free electron. Okay, on each of the one free electron on each of the carbon atom, and it can conduct electricity, being non-metal, but it has free electrons, so that's why it can conduct electricity. And platinum is the metal, it can also conduct electricity, but these do not react to the product, so that's why they are called the inert electrodes. So what we use over here, in case of concentrated NaCl, we use here electrodes carbon. So you will think that how carbon can react, can conduct electricity. Of course carbon cannot conduct electricity because it is the non-metal, but in case of graphite, okay, it has ability to conduct electricity, so graphite is used over here. Okay, both electrodes are the graphite, it is inert. Because chlorine may react, if we use here iron or some other which can conduct electricity but is the reactive, so chlorine will react with that, and some other products will be formed and it will be consumed. Okay, so that's why to avoid the reaction of the product with the electrode, we have to use over here inert electrodes, just like graphite. and we use here, in case of dilute, what we use over here, platinum. Okay, these electrodes are platinum. Okay, the next is electrolysis of water. Simply we take the water and the, okay, so what happens over here, but now let me tell you the electrolysis of copper sulfate solution. Copper sulfate aqueous. Okay, very simple. Over here we write the all of those four steps after drawing the diagram. Okay, plus charge, minus, this is the battery, this is the cathode. Okay, minus charge, this is the anode, it has a with charge, plus charge. Okay, and here is the electrolyte, which is the copper aqueous. Okay, diluted is. So let me write this first step. Select the cations and anions. Copper plus 2, SO4 minus 2, H plus and OH minus. Is it clear? Okay, on the cathode, what happens? CR, reduction takes place. And what is reduction? Reduction is the gain of electron. Okay, so from these two, which will be preferred? You know, in the reactivity series, copper, for the copper is easy to be discharged as compared to the hydrogen. Okay, copper and silver are discharged preferentially as compared to hydrogen. So copper will gain electron because it is the gain of electron. Reduction is the gain of electron. So copper solid will be formed and it will be deposited on this. Okay, a bit pink color, you can say. Okay, reddish brown, you can say it has a color. Okay, so next is on the anode, what happens over anode? Oxidation. Oxidation is IL. You can say that oxidation is the loss of electron. Oxidation is loss. Okay, so anions will move over here, which are the anions? Sulfate and hydroxide. Okay, so this hydroxide, what will happen on this? This will be preferred, it will not be discharged. Okay, even if the concentrated, it will not be discharged. Okay, so hydroxide, we write its famous example for OH. So 2H2O plus O2 plus 4 electrons. In the form of gas it will be released. Okay, oxygen will be released over here. So one more thing which we had to make it clear over here, that which type of electrodes we will take over here. Okay, so we can take here the inert electrodes. You can say that we can take here the copper anode. Okay, so we could make like this as well, and here copper will be deposited, or simply its diagram in your book is given a bit reverse form like this, so that you have a solution like this. Okay, and this drawing doesn't matter, but you have to understand the main thing, which is the process, the procedure. Plus over here, minus over here, this is the anode, this is the cathode. Okay, on anode what is formed? Oxygen gas will be here. Okay, it will be oxygen. And in case of anode, this is anode. Okay, in case of anode, oxygen will be formed. In case of cathode, what will be formed? This is the minus. Okay, so copper will be deposited. Okay, so that's why. And you must know that one more thing, that the solution of the copper sulfate is blue. Okay, this solution is the blue, it will remain blue. Okay, till here is blue, this is entirely blue. So fourth step is the remaining, which I have to write. So what are the remaining ions and what will be left over here? So hydrogen is remaining and here the sulfate is remaining. Okay. So and the blue color which was over here, it will fade. Okay. Blue color will fade. Blue color of copper sulfate will fade up. Reason is because copper is being used over here. It is no more copper sulfate, so that's why. Okay. And equation is 2H plus SO4 minus 2, so S2SO4 will be left. Okay, just diagram had the issue which I have discussed over here. The process, the steps are the same which I told you above. Okay, what are the applications or industrial application of electrolysis? Industrial applications of electrolysis. There are two main applications which we study. One is the purification purification of metals. Okay, like copper. Mostly copper has to be taken in the pure form to keep its conductivity up to the mark. And the second thing is the electroplating. Okay, to avoid the rusting and to make something appear okay good, and to for its good appearance. Okay, so purification first is the first step is the, I'm writing here, purification of copper. You should know that copper that we need in our daily life to make the cables, it has to be 99.9% pure. It has to be very pure. It has to be very pure to be used. Okay, in the same way other metals can also be used for purification. So I'm just writing over here that we have this electrolytic tank. Here anode will be of copper, which is the impure. Cathode will be of the copper, which is the pure copper. Okay, on which the, so not in this one, pure copper, and this is the impure copper. Okay, this is anode and this is a cathode. Okay, this is the battery, and here we take salt of the aqueous salt of the copper. Okay, so we simply take here copper sulfate aqueous. Okay, copper sulfate aqueous. So what will happen as the this reaction proceeds? Simply we connect these two terminals, or we connect these electrodes to the battery. Okay, terminals of the battery. So on the anode, copper will be oxidized. So copper Cu will lose electrons, so it will become copper plus 2. As compared to sulfate, SO4 minus 2 will not be oxidized. Okay, so and 2 electrons will be released, which will be given back. Okay, and electrons are given back over here. So this copper, which is aqueous, here it was a solid. Okay, so as it releases electrons, it become soluble over here. Okay, so now it will move over here, and you will see that copper will be on the cathode will be reduced. You know that on the cathode reduction takes place, and reduction is the gain of electron. So copper Cu plus 2 will gain electrons, and copper solid will be deposited on this. So only the copper which is being oxidized over here will be reduced over here, and this will become a bit thick, and this will start becoming thin. Okay, you can say it will become thin with the passage of time. Okay, so the copper sulfate aqueous, its color is blue. Okay, and it will not fade up. What's the reason? Because no copper will be taken from the copper sulfate. Okay, only copper which is being oxidized, copper being oxidized on the anode, which has the plus charge. Okay, so will be reduced over here. So from here, the copper which is the impure, okay, it has some impurities. The copper will here be oxidized and will here be reduced. Okay, on the opposite side on the cathode. So the remaining impurities will make your anode mud. Okay, this we simply call it anode mud, or you can also name it impurities, or anode mud. Okay, next is the electroplating. Okay, we can also use the copper sulfate. Okay, so we don't have to use here we use the reactive electrodes. Okay, this thing you have to keep in your mind. We don't take the inert electrodes. The next is electroplating. Okay, making our process of coating a thin layer of the metal, process of coating a thin layer of metal on other metal, on another metal, is called electroplating. The metal which has to be coated is called object. One is object and other is the coating metal. Okay, one is the coating metal and the second is the object. And the coating metal would make it the anode. Okay, and the object is taken here. Okay, we can take here object over here. Okay, um, it is made the cathode. And salt electrolyte means the salt of this metal is taken. Salt of coating metal is taken. Metal is taken as electrolyte. So coating metal is taken, which has to be electroplated on the positive, that is taken anode as the positive. Okay, and the object which has to be coated is taken as anode, is taken as cathode negative. Okay, and the salt of the coating metal is taken, aqueous salt of the coating metal is taken as electrolyte. Okay, so here we go. So we have electrolyte tank. Okay, here is the anode made up of the copper. We are electroplating copper on an object. Okay, object, I'm taking here spoon or anything you may consider. Okay, anything it can be. This is the object, this is the cathode, and cathode minus charge, and it is object over here. Okay, and this is anode which has the plus charge, and the coating metal is here. Okay, and this is the battery, plus or minus. Here is the battery, and here is the electrolyte is the copper. So sorry, we take the we are going to electroplate copper on the object. So here is copper, so it will be copper sulfate solution. Okay, okay, dilute solution. So what will happen on the anode? anode, the copper from here will be oxidized, it will lose electrons, okay, and those electrons will be given to this, okay. So you can see over here the oxidation takes place, and next the same copper will move towards the cathode, okay, Cu plus 2, okay. Here is the oxidation and here is the reduction, okay. So this copper Cu plus 2 will gain electron. You know that cathode is on the cathode, reduction takes place, okay, and reduction is the rig is the gain of electron, okay. So two electrons will be gained by the copper and it will become, sorry, copper solid, okay. So this copper solid will be deposited on this, okay, a thin layer of the copper solid will be formed, okay. So why we can use it, why we use this electroplating? We use this electroplating to make something appear good, to improve the appearance. Okay, the second thing is to avoid rusting. As we electroplate to zinc, that is called galvanizing, okay. Okay, to improve the, we use the tin to coat the aluminium, okay, tin coated, okay. So these are some applications, okay, which you have studied over here. So it's enough for today. Revise all that which I have taught you right now. See you in the next class. Best of luck.